All right, guys, so on Friday, we talked about congruent triangles and just about what they mean, how to write congruent statements, and how to find the corresponding sides and angles in congruent triangles. So what we're going to start working on today is, now I'm going to be giving you two triangles, and I'm going to give you some information about the triangles, but you are going to need to decide if the two triangles are congruent or not. So I'm not going to tell you if they are or not. I'm going to give you some information, and then you're going to have to decide if the two triangles are congruent, okay? So today, we're going to be talking about what is called the side-side-side congruence theorem, which is one thing that's going to help us determine if two triangles are congruent. So let's read what is up here at the top. How about you guys elect one person from your group to read the first paragraph to the group. Here's what it says. In mathematics, you often have to prove that a solution is correct. That's what we've been calling justifying your answer, okay? Specifically in geometry, theorems are used to verify statements, and then I gave you the definition of a theorem. A theorem is a statement that can be proven true using definitions, postulates, or other theorems. A postulate is a mathematical statement that cannot be proved but is considered true. So there are some mathematical statements that you actually can't prove, but we can't disprove them. So we consider them true. While you can assume that all duplicated or transformed angles are congruent, mathematically you need a theorem to prove it. So even though we looked at different congruent triangles and we know that their sides and their angles are congruent, you actually need a theorem in order to prove it. You can't just say, I know it, so it's true. Okay? So that's where the side-side-side congruence theorem comes in. The side-side-side congruence theorem is one theorem that can be used to prove triangle congruence. The side-side-side congruence theorem states that if all three sides of one triangle are congruent to the corresponding sides of another triangle, then the two triangles are congruent. So if we make two triangles that have all three sides exactly the same size, we can use the side-side-side congruence theorem to prove that they are congruent. So part one, we're going to kind of do that. So it says, use the given line segments to construct triangle ABC. Then write the steps you perform to construct the triangle. I'm not going to make you write the steps, but we are going to construct the triangle together. Any ideas of how we can construct a triangle using these three given side lengths? Measure it with your compass. Undo a little arc on the starter line. So first we need to copy one of the line segments. So using your straight edge, will you guys make a starter line on your paper? And which segment do you guys want to copy first? AB, BC, or AC? AB? BC? It doesn't really matter. I'm going to do AB because it's the longest one. So let's copy AB. If you want to copy a different one, that's fine too. Just make sure you're doing the same steps that we're doing so that your triangle all has the same length. So if you want to copy a different segment, you can. So you draw your arc. That intersection point for mine is going to be AB. Okay, so we copied one of the segment lengths. Any ideas as to how we can copy the other one? If I draw another line going through, let's say, point A, and then I draw an arc to make AC, does that guarantee that the other line is going to be point BC, the same length? Do you guys see what I'm saying? If I draw just some random line going through point A, and then mark the spot where AC is the right length, does that guarantee that BC will be the correct length? No. So any ideas as to what we could do? Measure the length of BC. Okay, so if we measure the length of BC, Which point then do I have to use in order to draw an arc? Can I use A or do I have to use B? You have to use B. So if we draw an arc from point B that's the length of BC, what could I do next? Okay, so Tong said if we do the length of AC, put it on A, and do that exact same thing, what happens? What do you guys notice? They intersect. So if I draw that intersection point, now can I draw the lines? So this intersection point is C because we did BC and then we also did AC. So now we can use our straight edge to connect all three.
That line right there, it has to be the length of AC?
This one will be the length of AC and this one will be the length of BC. We can check it too. If we open up our compass to AC and then open it up to AC here, it's the right length. And if we open our compass to BC and then we check it on BC, it's also the right length. So we can't just draw a line going through AC or going through A and putting the point C because that doesn't guarantee that BC will be the right length. But since we used the two arcs and we took the intersection point, that means that where they intersect, both of them will be the right length. Okay, so we copied all three segments to make triangle AB. Do you guys want to write those steps down so that you can do it again? Yes, no? Yes? Okay, let's write those down. So first we copied segment AB. You don't need to write all the steps to copying because you guys should know that by now. And then what did we do? We drew an arc that was the length of what? BC. So draw an arc. That is the length of and then we drew a second arc that was the length of what? AC. So draw a second arc. That is the length of AC. And then what did we do? Connect all the intersection points. So then we connected intersection points. So that way if I ask you to draw another triangle with the given length, you can do that again. Okay, so what I want you guys to do now is flip your paper over, read questions B and C, and answer them with your group members. Okay guys, so part B says to compare your triangle to your classmate's triangle, are the two triangles congruent, why or why not? Hands up, how many of you said yes, the two triangles are congruent? Yours and all the other people's in your group. Did anybody say no? Okay, then what is the reason that you gave as to why the triangles are congruent? Okay, we use the same measurements, we use the same sides, so your answer needs to have something like that written down. So I wrote something like that. Yes, the triangles are congruent because everyone used the same side lengths. So then let's talk about part C. How many different triangles can be formed given the length of the three sides that I gave you? Any ideas? If I give you these three side lengths, how many different triangles could you make that have all three of those side lengths exactly like that?
9.
Let's think about it, guys. You have to use these three side lengths. Talk about it in your groups. Okay, guys, anybody come up with an answer? Why 6? Why? You have to give me a reason. You can't just say 6.
You can have 3 different triangles with those measurements, and then you can use them differently.
Okay, so let's imagine cutting out all 3 of these lines and you were rearranging them. So you think you could make 6 different triangles? Anybody disagree? Jordan, what do you say?
You can only make one triangle. They can be in there, because the length is the same size, but they can be in like different angles.
Okay, so what Jordan is saying is you can only make one because you have all 3 of those side lengths, but you can rotate the triangle, but does that make it a different triangle? No, so how many triangles can you actually make? Just one. Okay, so only one unique triangle can be formed with a given side length. That's the whole point of the side congruence theorem. And you guys just said that. If I took Jordan's triangle and compared it to Tong's triangle, it doesn't matter how they drew the lines, all 3 sides are the same, so the 2 triangles are congruent. So you can only form one triangle. Okay, so only one unique triangle can be formed. Okay, that's because, guys, even if you rotate or flip or move your triangle around, if all 3 side lengths are the same, they're still congruent. They're still the same triangle. Okay? Does that make sense? So, guys, we're going to prove this using actual measurements because when you are not given measurements, so for example, like in problem 1, and I just gave you the picture of the triangle, you can use the theorem. If I make you graph the triangle on a coordinate plane, you have to use the measurements to prove that all the sides are congruent. So what we're going to do is we're going to start by graphing triangle ABC on the coordinate plane. Okay, so point A is 8, -5, point B is 4, -12, and point C is 12, -8. So graph that for me right now, triangle ABCD. Okay, guys, so your triangle should end up looking like this. Does everybody's triangle look like that?
Yeah.
Okay, good. So you have to make sure that you're being careful about your units because it looks like each grid line is worth 2. So on point A, where we're going to 8, -5, you have to go halfway down between -4 and -6. So A is the only one that's right in between 2 grid lines. So what we're going to have to do is we are going to find the length of each segment on the triangle. Then we're going to move I'm going to give you another triangle, and you are going to have to find the length of each of those sides and then determine if the 2 triangles are congruent. How can you determine the length of each side of the triangle? Distance formula. So will you write distance formula down for me? Okay, so we're going to have to use distance formula to find the length between AB, to find the length between BC, and then to find the length between AC. So that's what we're going to do. I give you the points up at the top, so those are the points we're going to use. So just as a reminder, distance formula is D equals the square root of x1 minus x2, and then we square it, plus y1 minus y2, and then we square it. Does the point that we pick for x1, y1, and x2, y2 matter? No, because we end up squaring it, so it ends up being positive. The only thing, remember, that you have to remember to do is if whatever point I use for x first, you have to use that point for y first. So you have to go in the same order. We are going to do all of the lengths together on this one, and then with the new triangle, I'm going to have you guys do them all by yourself, okay? So let's do AB first. So the distance between AB. Guess what? I'm not even going to make you use your calculators. We're going to just leave everything inside the square roots, okay? So we're looking at the distance between point A and point B first. So I'm using these 2 points that are given to me, 8, -5, and 4, -12. Which point do you guys want to use as x1? Do you want to use 8 or do you want to use 4? 8? Okay, so that's going to be in parentheses, 8 minus 4 squared plus, now since I used 8 as my x1, which y do I have to use as y1? Negative 5. So that's going to be negative 5 minus negative 12 squared. Equals, inside the big square root. Okay guys, what's 8 minus 4 give me? 4, so that's going to be 4 squared plus, now up here I have negative 5 minus negative 12. What happens when I subtract a negative? It all becomes positive. So what would negative 5 plus 12 be? Positive 7 squared. Okay, 4 squared is 16 plus 7 squared, which is 49, equals, what's 16 plus 49? 65. Is 65 a perfect square? Can I take the square root of it? So you can just leave it as square root of 65 because that's an exact measurement. You don't have to plug it into the calculator, okay? So in our chart where it says length of segment AB, just put the square root of 65. It is a number. We could plug it in the calculator and figure out what it is. We're not going to spend that much time. We're just going to leave it as square root 65. For the homework, I want you to leave it that way because when we plug it into a calculator, it actually gives us an approximation. Remember, it gives us the decimals and we round. I want exact measurements. So square root of 65 is the exact measurement. Okay. Okay, so let's do BC next. So just off to the right, I'm going to do BC equals square root. Okay, guys, so for x1, do you want to use 4 or do you want to use 12? 12. Okay, so that's going to be 12 minus 4 squared plus, so since we use 12 as x1, what do we have to use as y1? Negative 8. So that's going to be negative 8 minus negative 12 squared. So that equals the square root. What's 12 minus 4? 8. So that's going to be 8 squared plus negative 8 minus negative 12. So everything becomes positive. So what's negative 8 plus 12? 4. So that's going to be 8 squared plus 4 squared. Equals, ladies and gentlemen, what is 8 squared? 64 plus, okay, what does 64 plus 16 give us? 80. Is 80 a perfect square?
No.
No, so we're going to leave it as the square root of 80. Okay. Last part. We need to find the length of AC. So that's the square root. Okay, guys, for x1, do you want to use 8 or do you want to use 12? 12. Okay, so that's going to be 12 minus 8 squared, because we're using points A and point C, plus, so since we use 12 as x1, what do we have to use as y1? Negative 8. So negative 8 minus negative 5 squared. Equals. We're almost done, guys. What's the square root, or what is 12 minus 8? 4, so that's 4 squared, plus, okay, negative 8 minus negative 5. That all becomes positive. What's negative 8 plus 5 going to give me? Negative 3. So make sure you put in parentheses negative 3 squared. Okay, 4 squared gives us what? Plus negative 3 squared is 9. What's 16 plus 9? Okay, so the square root of 25. Can we take the square root of 25? Yeah, what is it? 5. So the length of AC is 5. Okay, so that's triangle ABC. Turn the page and let's see what it wants us to do. It says, translate the line segments AB, BC, and AC up 7 units to form triangle A prime, B prime, C prime, and graph the image. I also want you to give me the coordinates. Okay, so you're going to translate triangle ABC up 7 units, and then give me the coordinates for A prime, B prime, and C prime. Okay, guys, what did you get for the coordinates of A prime? 8, 2. Do you all agree? Okay, I agree too. What did you get for B prime? 4, -5, and C prime? 12, -1. So here's what I want you guys to do. Your triangle should have looked like this. Now I want you to find the lengths of A prime, B prime, B prime, C prime, and A prime, C prime. So do exactly what we did in number 3. So do exactly what we did in number 3, but now you're going to use the coordinates for A prime, B prime, and C prime. Find the lengths. Let me know what you get. Okay, guys, what did you notice about all the side lengths? They're all the same, right? I showed all my work here. So you should have got that segment A prime, B prime was square root of 65. Segment B prime, C prime is the square root of 80. And segment A prime, C prime should have come out to 5. You need to show all of your work for that, because on the test, I will ask you and you will need to show your work. So, the last 2 questions I have for you are the corresponding sides of the pre-image and image. Remember, the pre-image is the original, the image is the new one, so pre-image and image. Are they congruent?
Yeah.
Yes or no? Yes. Why are the 2 triangles congruent? Because all sides are the same length. So you need to write something like that. All sides are the same length. So my last question to you is, do we need to know what the measures of the angles are in order to determine if the triangles are congruent? No. Why? Exactly. No. Because if the sides are the same, then the angles are the same, and we can use side, side, side congruence theorem. Because the sides are all the same, so side, 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 and we can abbreviate side, side, side by SSS. Side, side, side theorem says the 2 triangles are congruent. Okay? So knowing the length of all 3 sides is enough to determine if 2 triangles are congruent.